We took tree cores from a bunch of sugar maple trees at Hubbard Brook and found that when you have a smaller snowpack and increased soil freezing in winter, those same sugar maple trees reduce their ability to grow and sequester carbon can be reduced by 40%. So that's a lot. That's a huge amount of carbon that is not being pulled out of the atmosphere. One of our major projects at Hubbard Brook is to look at how changes in climate are affecting the function and the health of the forest ecosystems. So many people around the world are familiar with the fact that temperatures are rising around the globe, but what some people might not be familiar with is the fact that temperatures in winter are rising faster than the rest of the year. And what that has meant for this region of the world in the northeastern United States is that air temperatures have been rising in winter, of course, but also that the winter snowpack is shrinking. And so that means both in terms of how much snow is falling, how much snow is staying on the ground, and the duration by which snow is on the ground. And we know from indigenous peoples all around the globe that snow acts as a great insulator. It's why they build their homes with it. But snow also acts as a great insulator of the forest floor, so that in winter, if you have a sufficient snowpack, even if it's extremely cold outside, if snow covers the ground, then all the great organisms that live below it are not likely to freeze. And that's in contrast to a day where you and I might consider it mild, but as long as the ground is not covered in snow, if the soils are exposed to below freezing air temperatures, they're likely to freeze. And so we've found that a smaller snowpack is really detrimental to the functioning and health of our forests because it negatively impacts roots, it damages them. The trees can't take up as much nitrogen or water or carbon in the following growing season. There's also fewer arthropods in the soil, a smaller amount of diversity of those arthropods, microbial activity goes down. So basically a lot of negative things are associated with warmer winter temperatures and a smaller snowpack. And we know that winters are not the only season that's changing. The growing season is changing as well. They're getting warmer, they're getting longer. And so we set up the Climate Change Across Seasons experiment, also known as CCASE, at Hubbard Brook in 2012, and it's still ongoing, so that we could look at the combined effects of basically warmer temperatures, but a smaller snowpack in winter and warmer temperatures in the growing season. So for example, it's predicted that air temperatures are going to rise another 5 degrees Celsius or 9 degrees Fahrenheit over the next century. So that's the increase in temperatures we've added in our warmed plots. And at the same time, we know that the winter snowpack is going to continue to decline. And we know from very specific models of the region, it's projected that the number of freeze-thaw cycles are going to increase by about 4 by the end of the century. So in wintertime, we aim to induce 4 freeze-thaw cycles per season. And by doing these two changes, our hope is that we're mimicking what the conditions are going to be for this forest over the next century. And by looking at the responses, things like carbon, nitrogen cycling, water, insects, plants, microbes, as many things as we can, we'll have a better understanding of how these forests are going to change over the next century.